Today I am going to begin current, electricity, electric resistance and Ohm's law. So about this chapter you are already familiar, you have already studied in class 10. Many topics of this chapter you have already studied. But once again I will revise them and then there are some new topics also. So first is what is electric current? So electric current is produced by the flowing charge. Flowing charges constitutes electric current. This you can see here in the diagram. You can see if charge flows from one point to another, then what will happen? Current will be constituted. मतलब अगर charge क्या होगा flow करेगा तो क्या हो जाएगी? Current produce हो जाएगी. It's clear. Now here in an electrolyte, current is constituted by the flow of positive and negative ions. But in a metallic conductor, हम लोग क्या है metallic conductor के लिए ज़्यादा concerned है. क्यों? Because here current electricity we deal with the metallic conductors. Now metallic conductor means copper wire, silver wire, gold wire, iron wire. Through these electric current can conduct. It's clear. So see here, as you know that in metallic conductor there is a very large concentration of free electrons. Free electrons का concentration metallic conductors में क्या है? बहुत ही अधिक है. Now what is the number of free electrons per unit volume? It is 10 to the power 29 per meter cube. Means in 1 meter cube volume there are how many free electrons? 10 to the power 29 per meter. This is the free electron density in the silver. Silver is considered as the best conductor. While if you see the iron, copper, gold, which are considered as the good conductor, in that, what is the free electron density? It is 10 to the power 24 per meter cube. Means in 1 meter cube volume, there are how many free electrons? 10 to the power 24. Now, these free electrons are moving randomly here and there inside the conductor because of the thermal energy of the conductor. Means these free electrons do not move in a definite direction. They are not moving in a definite direction. वो एक definite direction में नहीं move कर रहे हैं. They move just like the molecules of the gas. Their motion is random motion. उनका motion क्या है? एक random motion है. Now already I have told that the flowing charges produces electric current. Therefore, electron which is a charged particle which is having some amount of charge. कितना charge होता है electron पर? 1.6 into 10 की power minus 19 coulomb. So when one electron moves from here to here, what will happen? It will produce the electric current opposite to the direction of motion. Means suppose current is flowing in this direction, what will be the direction of motion of electrons? Electrons will move opposite to that direction. So see here, individual motion of the each electron will produce the electric current. Individual motion of each electron will produce the electric current. But overall, there is no electric current in this conductor. And why there is no electric current in this conductor? Because current produced by one electron will be neutralized by other electrons. जो एक इलेक्ट्रॉन करंट प्रोड्यूस कर रहा है, that is being neutralized by the other electrons. Therefore, there will be no net current in the conductor. You can say, in the other words, you can say that equal number of electrons are crossing to any cross section from the either side. मतलब क्या है? If 50 electrons crosses to this cross section from left to right in a given time, then 50 will cross from right to left in the same time. Means overall flow of the free electron over this cross section will become zero. मतलब overall flow क्या हो जाएगा? Zero हो जाएगा. मतलब current क्या हो जाएगी? Zero हो जाएगी. Current क्या हो जाएगी? Zero हो जाएगी. So in a metallic conductor, though free electron moves randomly, but they do not constitute any net electric current in the conductor. They do not produce any net electric current in the conductor. And why? Because the current produced by one electron will be neutralized by the other electron. So net current in the conductor will be 0. तो अब ये current produce कब? When these free electron will start moving in a definite direction. When they start moving in a definite direction, means directional flow of free charge in a conductor produces the electric current. Directional flow of charge in a conductor produces the electric current. Means when these free electron move in a definite direction, then only electric current will be produced. And this directional flow produces when some potential difference is applied. It's clear. In the absence of potential difference, what will be? In the absence of potential difference, these electrons will move randomly like this. They will move through the vacant spaces between the positive ions. ये positive ions कहाँ से आ गए? The atoms which are losing the electron will become positively charged. It's clear. So these free electrons which are shown by the red color here, they are moving through the vacant spaces between the positive ions. It's clear. Since they are moving randomly, therefore there will be no net current. कोई भी net current क्या होगी? नहीं होगी. It's clear. Here, the next slide you can see. Here also you can see that electrons are moving randomly. It's clear. One electron starts from here, then moves through the vacant space and goes in this direction. Other goes in this way. Third goes in this way. Means they are moving randomly and there will be no net current in the conductor. Here, this also represents the random motion of free electron. But in the next slide, you will see, here you can see that when some potential difference is applied, when we apply some potential difference across the ends of conductor, you can see this indicate higher potential, this indicate lower potential. ये 220 वोल्ट पर है, ये क्या है इंड 0 वोल्ट पर, ये वाला इंड क्या है 220 वोल्ट पर है, ले लिया 220 वोल्ट. Yeah, this is suppose at 2 volt and this is at 0. Then what will happen? All the free electron will start moving from low potential to high potential. Their motion will be in one direction, and when their motion will be in one direction, what will be? A current will be produced. A net current will be produced in this conductor. इस कंडक्टर में क्या हो जाएगी? एक करंट प्रोड्यूस होगी. उस करंट की डायरेक्शन क्या होगी? You can see here. Direction of that current will be, I am showing you. It is opposite to the motion of free electrons. Free electrons जिधर जा रहे हैं उसके opposite. Means you can see that moving charges constitutes the electric current. This is correct. But in any metallic conductor, when free electron moves randomly, they do not produce any net current in the conductor. And why? Because the current produced by one electron is neutralized by the other electrons. Net current becomes 0. Net current क्या हो जाती है? 0 हो जाती है. It's clear. But if you make their flow directional, how can you make their flow directional? By applying some potential difference across the ends of conductor. मतलब अगर कंडक्टर के ends के across एक हम potential difference apply करते हैं, then what will happen? जितने भी free electrons within the conductor हैं, they will start moving in a definite direction. Suppose this indicate 12 volt. It's clear. And this is at 5 volt. Then what will happen? जितने भी free electrons हैं, they will start moving in this direction. And current will be produced opposite to that. It's clear. So it is the directional flow of charge in a conductor under a potential difference produces the electric current in that conductor. In other words, when the charge flows in a conductor from one place to the other in a particular direction, then only current will be produced. Now see here, what will be the magnitude of this current? There is one more thing before that. You can see here, as the motion of free electrons is random, their motion within a conductor is just like the molecules of gas in a enclosed vessel. Therefore, we assume that these free electrons within the conductor constitutes an electron gas. These free electrons within the metallic conductor constitutes an electron gas. Their concentration is very huge. About the concentration already I told. In silver it is 10 की power 29 per meter cube, जिसको हम लोग क्या कहते हैं फ्री इलेक्ट्रॉन डेंसिटी के सिंबल से डिनोट करते हैं. फ्री इलेक्ट्रॉन डेंसिटी डिनोटेड बाय स्मॉल n. Its value for the silver is 10 to the power 29 per meter cube, while for copper, for aluminum, for iron, for gold, it is 10 की power 24 per meter cube. 1 meter cube volume में 10 की power 24 per meter, 10 power 24 free electrons. So since the free electrons number is very large, they move randomly like the molecules of gas in an enclosed vessel. Therefore, free electrons constitute an electron gas within the conductor. मतलब free electrons कंडक्टर के अंदर एक ऐसी गैस कॉन्स्टिट्यूट करते हैं, कोई गैस नहीं होती है, उनका मोशन एज गैसियस मॉलिक्यूल्स की तरीके से है. इसीलिए फ्री इलेक्ट्रॉन्स को क्या कर दिया गया they constitute an electron gas within the conductor and their motion is governed by the gas laws. It's clear. So this is the new thing. Now what will be the amount of electric current? Current का कितना magnitude होगा? So see here, how will you measure the electric current? Electric current is measured by the rate of flow of charge. It is the charge flowing through a conductor in 1 second. Or in other words, this is very important point. What is its meaning? It is the rate of flow of charge through any cross section of the conductor. It is the rate of flow of charge through any point of the conductor. That is called the electric current. वो electric current का magnitude कहलाता है. Suppose here this is one cross section. You can see here. This is one cross section, and here Q charge crosses to this cross section in time t. मतलब Q charge इस cross section को t टाइम में क्रॉस कर जाता है. ये Q चार्ज जो है t टाइम में इस क्रॉस सेक्शन को क्रॉस कर जाता है. What will be the electric current? It will be Q upon t. It is the charge flowing per unit time. Charge flowing per unit time. Here one thing which I want to clarify, that it does not mean that in t time Q charge moves from here to here. मतलब लेफ्ट एंड से कंडक्टर के राइट एंड तक पहुंच जाता है, ये नहीं. Q चार्ज t टाइम में किसी क्रॉस सेक्शन को क्रॉस कर रहा है, क्रॉस सेक्शन के इस एंड से इस एंड में चला जाता है in t time. Therefore electric current is said to be Q upon t. It does not mean that Q charge travels from one end of the conductor to the other end in time t. It's clear. So this thing should be very, very clear. In other words, if Q charge enters through this cross section, passes through this cross section in time t, मतलब इस क्रॉस सेक्शन से t टाइम में Q चार्ज कंडक्टर के अंदर इंटर कर रहा, तो इस वाले क्रॉस सेक्शन से t टाइम में Q चार्ज क्या हो जाएगा, बाहर निकल जाएगा. मतलब जितना चार्ज इंटर करेगा इन ए गिवन टाइम, उतना ही चार्ज एग्जिट आउट हो जाएगा, लीव आउट हो जाएगा फ्रॉम द अदर एंड ऑफ द कंडक्टर. दिस थिंग शुड बी वेरी वेरी क्लियर. अगर 10 सेकंड में 100 इलेक्ट्रॉन्स यहाँ पर इंटर कर रहे हैं, तो 10 सेकंड में 100 इलेक्ट्रॉन्स इसके दूसरे एंड से बाहर निकल जाएंगे. सो current is defined as the rate of flow of charge flowing through the conductor in unit time. That is called the electric current. If Q charge flows through the conductor in t second, current is said to be I equals to Q upon t. Then current will be equal to I equals to Q upon t. Now, as you know that in the metallic conductor, in the metallic conductor, current is constituted by the flow of free electrons. It is the free electrons which constitutes the electric current in any conductor. अगर क्या है, n free electrons crosses to any cross section in time t. किसी भी क्रॉस सेक्शन को n free electrons t time में क्रॉस कर जाते हैं. You can see here. You can see n free electrons passes to this cross section in time t. So how much charge will flow? So as we know that charge on one electron is 1.6 into 10 की power minus 19 coulomb, and this we denote by which symbol? Small e. So एक इलेक्ट्रॉन पर इतना चार्ज, तो n इलेक्ट्रॉन्स पर कितना चार्ज? n इलेक्ट्रॉन्स पर चार्ज हो जाएगा n into e. What will be the charge on n electrons? It will be equal to n into e. कितना चार्ज हो जाएगा यहाँ पर? n into e. So we can say that in t time how much charge passes through this cross section? n into e. Therefore current is given by I equals to n into e upon t. Is clear? This is another formula which is used for the metallic conductors. अब देखिए what will be the unit of electric current. So unit of electric current, it is ampere. That you already know that unit of electric current is ampere. Here you can see, if you reduce the unit of electric current from here, you know that unit of charge is coulomb, unit of time is second. It is coulomb per second. कूलम पर सेकंड को हम लोग क्या करते हैं? एम्पियर. इट्स क्लियर? कूलम पर सेकंड इज एम्पियर, एंड एम्पियर इज ए फंडामेंटल यूनिट. इट इज द फंडामेंटल यूनिट which is defined on the basis of the force acting in between two current carrying straight parallel conductors, that you have already studied in class 11 in fundamental units. There are 7 fundamental units. Among them, one is ampere, which is the SI unit of electric current. So about that you know. Now we will deduce the definition of ampere by using this formula. इस फार्मूला को यूज करके हम एम्पियर की डेफिनेशन डिड्यूस करेंगे. I equals to Q upon T. This is the formula. Now if 1 coulomb charge passes through any cross section in 1 second, 1 coulomb charge passes through any cross section in 1 second, current is said to be I equals to Q upon T. 1 coulomb upon 1 second, that is 1 ampere. Means current is said to be 1 ampere when 1 coulomb charge passes through any cross section of the conductor in 1 second. मतलब अगर क्या है, इस क्रॉस सेक्शन से 1 सेकंड में 1 कूलम चार्ज पास हो जाए, करंट इज सेड टू बी 1 एम्पीयर. सपोज इफ 10 कूलम चार्ज passes through this cross section in 1 second, current will be 10 एम्पीयर. 20 कूलम चार्ज 1 सेकंड में पास हो जाए, करंट इज सेड टू बी 20 एम्पीयर. इट्स क्लियर? 5 कूलम चार्ज अगर पास हो जाए 1 सेकंड में, then current is said to be 5 ampere. It's clear? So current is said to be 1 ampere when 1 coulomb charge passes through any cross section of the conductor in 1 second. Now in next slide I will explain that 1 coulomb charge is equivalent to charge on how many electrons. 1 coulomb का charge कितने electrons के charge के equivalent है? So you can see here, as we know that charge on 1 electron is how much? 1.6 into 10 की power minus 19 coulomb. Means this much charge is equal to charge on 1 electron. So 1 coulomb will be equivalent to how much? 1 के लिए क्या हो जाएगा? इस वैल्यू से डिवाइड कर देंगे. So 1 coulomb equals to charge on 1 upon 1.6 into 10 की power minus 19 electrons. Means this much number of electrons. Means 1 coulomb charge is equivalent to charge on this much number of electrons. Now already I have told that when 1 coulomb charge flows through any cross section in 1 second, you can see here, this is a conductor and in the cross section of conductor, you can see when 1 coulomb charge passes through this cross section in 1 सेकेंड, जब 1 कूलम चार्ज इस क्रॉस सेक्शन से 1 सेकेंड में क्रॉस कर जाता है, करंट इज सेड टू बी 1 एम्पियर। सो वी कैन यूज दिस वैल्यू 6.25 into 10 to the power 80, means instead of 1 coulomb we will say that when this much number of free electrons crosses to any cross section in 1 second, current is said to be 1 ampere. Current 1 ampere hogi when this much number of free electrons crosses to this cross section, any cross section in 1 second. Now one more thing, iska meaning kya hai, which already I have explained here, but you see once again, is it does not mean that, let me first make the conductor. अभी हमने बताया कि अगर किसी क्रॉस सेक्शन से इतने फ्री इलेक्ट्रॉन्स 1 सेकंड में क्रॉस कर जाए, करंट इज सेड टू बी 1 एम्पीयर। इसका मीनिंग ये कतई नहीं है कि इतने फ्री इलेक्ट्रॉन्स यहाँ से यहाँ तक पहुंचने में 1 सेकंड लगाते हैं। इसका मतलब ये कतई नहीं है कि इतने फ्री इलेक्ट्रॉन्स यहाँ से यहाँ तक पहुंचने में 1 सेकंड टाइम लेते हैं। इट मीन्स, इसका मीनिंग क्या है कि 1 सेकंड में किसी भी क्रॉस सेक्शन को इतने फ्री इलेक्ट्रॉन्स क्रॉस कर जाते हैं। मतलब 1 सेकंड में इतने फ्री इलेक्ट्रॉन्स यहाँ इंटर करेंगे, इतने यहाँ पर क्या हो जाएंगे, निकल जाएंगे। मीन्स ऑन द होल this current, this conductor will remain neutral. It will remain neutral. It's clear? जितने फ्री इलेक्ट्रॉन्स इन गिवन टाइम इंटर करते उतने ही क्या होंगे, दूसरे एंड से निकल जाएंगे। लोअर पोटेंशियल एंड से जितने फ्री इलेक्ट्रॉन्स इंटर करेंगे, यू कैन सी हियर दिस डायग्राम, लोअर पोटेंशियल एंड से जितने फ्री इलेक्ट्रॉन्स इंटर करेंगे इन 1 सेकेंड, उतने ही क्या हो जाएंगे, एग्जिट कर जाएंगे। जितने यहाँ से इंटर कर रहे हैं उतने ही यहाँ से निकल जाएंगे। मीन्स ऑन द होल दिस कंडक्टर विल रिमेन न्यूट्रल। ये कंडक्टर क्या रहेगा, न्यूट्रल रहेगा। सो दिस इज, नाउ सी हियर what will be the direction of flow of current. So already I told that direction of flow of current, it is opposite to the direction of flow of electrons in the metallic conductor. अगर metallic conductor ऐसे move कर रहे हैं, already you can see here in this slide, perhaps I explained here, electrons are moving from left low potential to high potential. Current will flow in what direction? Current will flow from high potential to low potential. Current will flow in this direction. It's clear? Means the direction of current is in the direction of flow of positive charge. It is in the direction of flow of positive charge. It's clear? What is the direction of flow? It is the direction of flow of positive charge. You can see here. Direction of flow of positive charge are opposite to the electrons. It's conventionally taken as the direction of current. This direction in an electric circuit is indicated by the arrow. Then current is a scalar quantity. It is not a vector quantity. Means इसको ऐसे समझ सकते हैं। Suppose इस ब्रांच से कितनी करंट आ रही है, 3 एम्पीयर। इस ब्रांच से कितनी करंट आ रही है, 4 एम्पीयर। ये दोनों ब्रांचेज एक दूसरे के क्या है, परपेंडिकुलर। तो इस ब्रांच में कितनी करंट जाएगी, सो इट विल नॉट बी इक्वल टू 5। ये यहाँ पर 3 है, यहाँ पर ये 4 है, तो इसका मतलब ये नहीं कि इधर 5 जाएगी, इधर 7 एम्पीयर जाएगी। इट्स क्लियर? सिंस इट करंट इज ए स्केलर क्वांटिटी, so it is added scalarly. It's clear? Then one more thing, current do not depend upon the cross sectional area. Current do not depend upon the cross sectional area means, suppose here this is a conductor of uneven thickness. ये यहाँ पर तो थिक है और यहाँ पर क्या है, थिन है। यहाँ पर क्रॉस सेक्शनल एरिया कम है, यहाँ पर क्रॉस सेक्शनल एरिया अधिक। बट अगर यहाँ करंट 5 एम्पियर है, here also current will be 5 एम्पियर। Means if 5 coulomb charge crosses to this cross section in 1 second, here also 5 coulomb charge will cross to this cross section in 1 second. Means current is a fundamental property of conductor which will remain same for whole conductor. वो पूरे कंडक्टर के लिए क्या रहेगी, सेम रहेगी. ये नहीं कि थिकर क्रॉस सेक्शन पे मोर एंड थिनर में लेस, ये ऐसा नहीं. इट्स क्लियर. So this is all about the current. Now next topic in this is current density. So which I will begin in the next lecture.